When most people tell you about climate change and global warming, they fall into two camps. One says that never happens and is not happening. These people are, of course, very silly. The second camp says that global warming may be equivalent to Venus' runaway greenhouse effect. Venus, in a picture, has a temperature that's hundreds of degrees more than what would be explained only by its distance from the sun. That camp, of course, exaggerates as well. If you click on a link below, you'll see a common explanation that most global warming scientists want you to see. Unfortunately, in my opinion, it's at the kindergarten level and it can do much more than that. The one below that is a conspiracy theory that is in part a result of that very limited explanation. Check your knowledge and see Venus in the previous picture has an ozone layer, thick atmosphere, sulfuric acid clouds, lakes of ammonia, or B, and C. I'll give you 15 seconds. I hope you got it right. It's B and C. Now, check this one out. Why does Venus have a runaway greenhouse effect that makes it super hot? Is it because it has carbon dioxide in its atmosphere? Is it because it is closer to the sun than Mercury is? Is it because it spins very slowly about its axis? Or is it because its orbit is circular? 10 seconds only, sorry. Well, it is because of the CO2 in the atmosphere. All the other B, C, and D are correct, but have nothing to do with the runaway greenhouse effect. Not only does it have carbon dioxide in its atmosphere, but carbon dioxide is 95% of Venus' atmosphere. Both on Earth and on Venus, we have a similar equation for warming of the atmosphere. But just a similar equation doesn't mean equivalence at all. For one thing, Earth's atmosphere reflects into space most of the sun radiation because of clouds. But whatever does hit the ground and the oceans is re-radiated into Earth's atmosphere, mostly in the infrared part of the spectrum, where carbon dioxide molecules readily absorb it, and the infrared radiation that's absorbed is turned into faster motion of the molecules, which warms them up. But let's try and see what that means and how that happened in the first place. I'll start with the history of the last 100 years or so. As you can see, the temperature has risen by about a degree. As you will see in the next graph, it was correlated with an increase in carbon dioxide in the atmosphere. There is a very strong correlation of this increase in carbon dioxide in the atmosphere measured very precisely in a mountain in Hawaii, so it's unrelated to local effects. And this increased from about 300 parts per million to about 400 parts per million took less than a century. If we zoom out from the previous graphs, we can see that looking from the 1700s onwards, the carbon dioxide in the atmosphere didn't just increase, but increase its rate of increase. Over the last few years, the temperatures have been fairly steady with a slight decrease due to ice ages and long cycles. We have to have a much clearer picture, and for that we have to look at 4.5 billion years of Earth's history. The carbon dioxide in the atmosphere is described with the purple line, the temperatures with the blue line. The purple line on the very bottom right, last few million years have been fairly constant, then there's been an increase. Now, why did carbon dioxide in the atmosphere follow such an interesting route? In very few words, it's due to oceans, it's due to life, it's due to the fact that we started with a lot of carbon dioxide as well. Let's add a few details. In order to do that, let's zoom in on the last billion of the 4 billion years, and let's look at oxygen only. As you can see, there was very little oxygen in Earth's atmosphere to begin with, and it went wild at about 600 million years ago. That's when life forms in the form of certain bacteria and certain planktons became very efficient at converting carbon dioxide into sequestered carbon and oxygen. Lately, oxygen settled at around 20% of Earth's atmosphere. Let's zoom out again and look at carbon dioxide in the atmosphere again. And the question is, okay, so we can see this decrease in carbon dioxide levels as life was increasing between 500 million years ago and about a few hundred million years ago. Then kind of varying, and each variation has to do with mass extinctions and the like. But why did carbon dioxide start so high, and how did it go so low? The very early Earth had a very large portion of carbon dioxide in its atmosphere. Most of it got sequestered in the oceans, turned in the oceans to soda water, more or less. Carbon dioxide was therefore not very common in the Earth's atmosphere fairly early on. Nitrogen was, because ammonia, the same thing that you use for cleaning, was very common, and the ammonia very easily broke because of ultraviolet radiation that was still in Earth's atmosphere because there was no ozone layer. Therefore, nitrogen broke out of this compound. Hydrogen actually escaped Earth's gravity, and the nitrogen itself settled into nitrogen too. Speaking of having no ozone layer to begin with on Earth, of course we had no ozone layer because there was no oxygen in the atmosphere, and O3, oxygen 3 in the upper stratosphere, is the ozone layer that protects us. That was our last amazing challenge that we figured out and solved. So I strongly believe in us, and I strongly believe we can solve the global warming and climate change problem. I like to keep you on your toes. So the question is, why does the Earth have so little carbon dioxide in its atmosphere? Read and answer in about 20 seconds. Of course, the correct answer is C. I promised you that the explanation of global warming and climate change may be a tad more complicated. One other ingredient is the reflectivity of Earth. The reflectivity of Earth, also called albedo in the graph that you're seeing, is going to be much less if we're using a lot of coal that produces soot. The nanometers below, between about 400 and 700, that is visible light. Longer than that, and that's infrared. That means that a lot of light that did not reflect into the atmosphere was absorbed by soot, and as a result re-emitted as infrared, and as a result increases Earth's temperature. The most obvious thing we can do is to reduce our dependence on fossil fuels. We did some of that between 2010 and 2017. One thing is, we doubled our use of renewables, but that's still at about 5%. Next thing we did was we changed from coal to natural gas. That is also a positive thing because that's a much more efficient way of producing energy and as a result less carbon dioxide. However, that's one thing that we can do. We can do much more. What else can we do? One of the main things, as you can see in this diagram from 4 billion years, is that life is the biggest solution. Plant trees. Make sure the oceans are a bit cleaner so that more plankton can grow. Make sure that coal power plants that are dirty power plants stop functioning. Reduce the amount of energy that you yourself are using if you can. But of course, you shouldn't stop living. Living is everything.